Today we are going to discuss about the new physical quantity called activity. This is the new physical quantity. You may not be familiar so far. That's why this is given in the textbook. This activity is a physical quantity that is mainly used in the radioactivity process. Either it may be a natural radioactivity or it may be a artificial radioactivity. The rate of decay that can be measured by using the factor called activity. So R is nothing but activity that can be measured by the formula called dN by dt. Already this dN by dt expression was already introduced while deriving the law of radioactivity expressions. So dN by dt is nothing but rate of decay. Rate of decay. What is the meaning of rate of decay? Rate of decay means how many number of radioactive nuclei they disintegrate per unit time. That calculation is called rate of decay. So dN by dt means number of radioactive nuclei that disintegrate per unit time is called as rate of decay. That dN by dt is simply called as R. That R is called as activity. So activity R is a physical quantity. Now we are going to get the expressions for other expressions for R. Already you may be knowing the term called expression called n is equal to n naught e power of minus lambda t. This is one of the important final expression that is arrived at the end of the law of radioactivity, law of radioactive decay. Are you clear? Now, in the case of n is equal to n naught e power of minus lambda t, we know very well that what is n? N is called the number of undecayed nuclei at that any instant. N means the number of undecayed radioactive nuclei present at any instant can be calculated by using this expression. So we know the basic fundamental expression. Now by using this expression, we are going to get another expression for R. Are you clear? Now we know very well that dN by dt is directly proportional to n, and then dN by dt is equal to minus lambda n. So these are all the derivations which were already used while deriving this expression. So here we can remove the negative sign, just we can take the magnitude alone. Dn by dt is equal to lambda. Instead of n, this expression can be substituted. This expression can be substituted here. So in bracket I am writing instead of n, n naught e power of minus lambda t can be written. Any doubt in this? Now here this lambda and n naught both can be combined. If both are combined, you will get lambda n naught e power of minus lambda t can be written. Both the two can be written within the bracket. Here the same dN by dt can be written. Are you clear? Already we have seen that this dN by dt is nothing but activity. So therefore this dN by dt can be equated with R. Are you clear? So look at here. Now you are getting you have got a new expression. We have arrived a new expression. So what is the new expression? R is equal to lambda n naught e power of minus lambda t. I will rewrite this. R activity is equal to lambda n naught e power of minus lambda t can be written. These two can be written within the bracket. Are you clear? Within the bracket it can be written. Now these two constants can be replaced by R naught. Are you clear? R is equal to R naught e power of minus lambda t. So this is the another expression. From this we are able to measure the activity at any instant. This is called initial activity of the sample. Are you clear? When t is equal to 0, clear initially how the sample it radiates the emission. Are you clear? How it decays. That initial activity of the sample can be calculated when t is equal to 0. That is called R naught. What is the meaning of R? R is called as activity of the sample at any instant can be calculated. This one also obeys the exponential uh, rules. Are you clear? So exponentially it decreases with respect to time. When time increases, the activity also decreases. When time increases, that exponentially R also decreases. Are you clear? So this one could be written within the bracket. R is equal to R naught e power of minus lambda t can be written, and I will write this thing within the block. Very important expression. Are you clear? Here also one more expression is written here. Look at the similarity between these two. Is it clear? Both are looking in a very similar manner. Are you clear? From this you are able to get the number of radioactive undecayed nuclei can be calculated at any instant. This one that gives you the activity of the sample at any instant. Are you clear? Here, uh, this R naught, a lambda n naught was replaced by R naught. I'll rewrite this. R naught is equal to lambda n naught can be written. Are you clear? So R naught is equal to lambda n naught. Therefrom, we are able to get one expression called lambda is equal to R naught divided by n naught can be written. Are you clear? This is another expression. Are you clear? This one could be used for any purpose to measure the R naught, provided lambda and n naught, if both are known, we are able to calculate the R naught. Initial activity of the sample can be calculated. By knowing n naught, the number of atoms, number of undecayed atoms, initially, if it is known, clear, when t is equal to 0, by knowing the disintegration constant, R naught can be calculated. Are you clear? So this is another important expression. Are you clear? So the ratio of R naught and n naught that gives you lambda naught. Could you understand this? Now I am going to derive one more expression. By using these two expressions, we are able to get the another expression. Let us take this one. R is equal to lambda n naught e power of minus lambda t can be written, and this expression can be divided by this one. So if it is divided by n is equal to divided by n naught e power of minus lambda t, you will get one more expression. N naught can be cancelled. E power of minus lambda t, e power of minus lambda t can be cancelled. So finally you will be getting R divided by n will be equal to lambda. That is, lambda is equal to R by n. Are you clear? This is another expression. Are you clear? So what is R? R is nothing but activity of any sample at any instant. That is nothing but R. At any time, at any instant is R. What is N? The number of radioactive nuclei undecayed at any instant is called N. If R is divided by N, you will get lambda. Look at here, this is another lambda expression. By using initial activity of the sample and the initial number of atoms, with the help of this another lambda can be obtained, but both the two lambdas are same. Both are giving the same disintegration constant. Look at the various formulas. Are you clear? So our ultimate aim is you should know what is activity. Activity is nothing but it's a physical quantity. With the help of this, we are able to measure the rate of decay. Rate of decay is nothing but how many number of radioactive nuclei that disintegrate per unit time. So clear? That measurement is called, that measure is called R. Are you clear? To measure the activity, certain units are there. Next, we are going to see what are the units which are used to measure the activity. Are you clear? Now we are going to learn what are the units which are used to measure the rate of decay, that is activity. Are you clear? The first basic unit is becquerel. Are you clear? Becquerel is the unit. Actually, is it clear? To honor the scientist becquerel, we are using this unit. So here we can write it as becquerel is the first unit. Are you clear? Simply it can be called as BQ. So becquerel is the very fundamental unit. and then this is the smallest unit. This is called as SI unit. Very important one. The SI unit of activity, if it is asked in the examination, is it clear? Related to SI unit, you have to mention like this. SI unit of activity is called, what is this? Becquerel. Now we have to learn what is 1 becquerel. 1 becquerel means 1 disintegration per second. 1 disintegration, if it happens in 1 second, 1 disintegration per 1 second is called as, what is this? 1 becquerel. What is 1 disintegration? If any one radioactive nuclei, if it decays in 1 second, such measurement is called, what is this? 1 becquerel. So that should be measured only in terms of 1 becquerel. 1 disintegration, if it happens in 1 second, it is shortly called as 1 becquerel. Are you clear? 1 decay per second or 1 disintegration per second is called 1 becquerel. And one more unit is also there. That is called, what is this? Curie. The second unit which is given in the textbook is, what is this? The standard unit of the activity is called Curie. Standard unit. There is a difference between these two. Standard unit to measure the activity is Curie. Are you clear? Now we have to learn what is 1 Curie. Are you clear? Curie definition will be often asked in the examination in 3 mark. You should know what is 1 Curie. 1 Curie, it is simply written as 1 CI. The short form of Curie is CI. To honor the scientist, Madam Curie, is clear, we are using this unit. 1 CI is equal to, there is a specific value which is given in the textbook, 3.7. 3.7 into 10 to the power of 10 disintegrations. If this many number of disintegrations are happening in 1 second, within 1 second, how many number of decays, how many number of disintegrations have to happen? This many number of disintegrations, that is this many number of atoms, they have to get decayed. That is called disintegration. If this many number of disintegrations are happening in 1 second, that is called, what is this? 1 Curie. 3.7 into 10 to the power of 10 plus 10 in disintegrations are happening in 1 second. That activity is called 1 Curie. Definition will be asked. Now we have to write the same Curie in terms of becquerel. Are you clear? 1 CI is equal to, write the same value, 3.7 into 10 to the power of 10. Instead of disintegrations per second, we can write it as becquerel, BQ. So 1 Curie is equal to 3.7 into 10 to the power of 10 becquerel. So there are 2 units, one is becquerel and another one is called Curie. Both of them will be often used in the problem. While solving the problem, these 2 units are often used. Be thorough with the conversions. Okay, thank you.